Hello and welcome back. My name is Corey and you're my rubber ducks, and we are building a programming language from scratch in the command line terminal. Vim is our editor. The language that we're building is Tang. That stands for template language. That is, the language that we're building is going to be it's designed as for use as a template language for generating templates for use like HTML templates and things like that. We are doing everything, like I said, old school in a terminal window in the console. Why? Because why not? It's fun and it helps me to learn those tools better. I've been saying all along, this is 100% live coding. There's nothing up my sleeves. I don't have anything pre-prepared. I have written a programming language twice before in preparation for this, doing it different ways each time. And this is not copying and pasting from that. This is, I may have notes sometimes on like syntax or the regular expressions that that I need to use with Flex or something. But anyway, it's all live coding, that's for sure. Which means you see all of my successes and mostly all of my failures, syntax errors, and everything else. That's all right. We want to jump in, and as usual, we're up on what episode number are we on? Episode 42. That's right. And so I normally show this. I guess I've got to make sure the window is active. If I say get log, the very last commit was episode 41, and if I say get status, no code changes have been made. So we're picking up where we left off. The last thing that we did was we added support for arrays into our language. So we can create an array and we can access elements of that array using a bracket, the square bracket syntax, right? Using that as an index. What we haven't been able to do yet, because we haven't written it, is we cannot alter the contents of an array. That's what we want to do next. So, thought I saw a spot on my glasses, but evidently I'm hallucinating. Okay, so that's where we're going to start. We're going to add index assignment. Now, let's back up. Let's think about how assignment works in our program at the moment. Right now, we have a stack. When a program is being executed, it has a stack, and I don't care if you think of it going up or down. It doesn't matter. But we have a stack, and we reserve places on the stack for the variables. And if we do a is equal to 3, whatever that 3 is as a computed expression, integer in this case, but that is wrapped in the garbage collected object, and so that we can pass it around. And you may have been wondering, why are we even doing this whole garbage collected thing? Because it seems sort of messy, and or maybe a little bit too much work. And the answer is because of what we're about to do right now. Up until now, every value that we've used has been stored on the stack. Now, with the idea of having an array or a list, depending on what language you're coming from, the terminology you might be familiar with, but an array is usually the more technical term. But anyway, with an array, only the container itself is stored on the stack, and everything that's in the container is no longer on the stack. I'm not going to say that it's on the heap, because our language doesn't quite use that architecture. We don't allocate things on a stack versus a heap. It's more that we track things on the stack, and anything not on the stack is not explicitly tracked. And that's why we're using this garbage collected container. It's something that we wrote, because it will keep track of the number of uses. It's not thread safe, not intended to be thread safe. In fact, we're doing it non-thread safe because it's only meant to be used in one thread, and we're doing that for speed reasons, but for execution reasons. But anyway, you can execute programs in different threads. That's not unsafe. It's the fact that one program execution will never share threads, so that's why it's okay to use this method. So it's safe within the context of the single thread. Yes. All right. So right now, the way our assignment works is that we just copy that garbage collected value onto the space in the stack. We replace whatever was there with this value. Well, now we're going to have, an a square bracket 3 is equal to something. And that is not going to fit into our paradigm because there is no a square bracket 3 on the stack to assign it to. There's going to be an a variable on the stack. So what we need to do is say, well, on the stack, that a value, we need to tell it to put that expression, that computed expression, at index 3. And that's a different type of instruction. That's what we've got to write. So the nice thing is we're not going to have to add any AST node types for this because we can use what we currently have. We, in fact, don't even have to add anything to our what word was I going to say? To our Bison, to our parser, to our grammar. The grammar is in Bison. We don't have to add anything to that because we've actually already written it. And I'll just show you that before we get too far into this. But for right now, let's do this. Make, clean, make, test, watch. Okay, so this will be compiling in the background and it'll be set up to start working. So first I'm going to show you, let's look at Bison. And I'm looking for the equal sign. Oh no, it's going to be all over the place in here, isn't it? Yes, it is. That's fine. These are not, it's an expression. So going down to the expressions, here's the expressions. And we've got our standard types. And right here, expression equals expression. And an expression can be a square bracket 3. That can be an expression. So that can be on the left-hand side. So that's fine. In fact, if we edit our test, assign identifier, yes. I'm going to create one that is, I was thinking about this the other day, and I know that this, well, never mind. Okay, 622. This is over 1,000 lines. I can't remember how to mark in Vim. I'll have to look that up. I used to know. But this is going to be a test, assign, and what kind of assignment? This is going to be an index assignment. And I haven't been doing it, but I'm going to start using braces for the enclosure. Why? Because then I can say auto p1 is equal to Tang base compile script and whatever I want this to be. And then I can say my expect equal and p1 dot execute dot out, and what do I expect it to be equal to? Something. And then if I close it now, well, I should add one more. There. For the next one, I just have to copy this, and I don't have to rename the P1 over and over to P1, P2, P3 like I was doing here. It's going to add a lot more braces, open, close, but it should save time. Should. And then if I say, let's see, ZC, yeah, I can close one of them. ZO, okay, good. To do my folding. All right, so what is this going to look like? We're just going to say A is equal to 1, 2, 3. And now if I print A sub 1, so 1, 2, 3. Now I'm going to copy this. Why? Because right in the middle, I'm going to put A sub 1 is equal to foo. What should the output of this be? It should be a 1, 2, 3, 1, foo, 3. That's what we're expecting. However, not going to happen. It's going to fail. So we got 2, 3, 2, 3. Do you know why? I know why. This should have been a 0, and I don't have a 3 at all. Now it should be 1, 2, 3, 1, 2, 3, but not 1, foo, 3. And it's because it doesn't know how to do this assignment. So let's fix that. We're going to, in order to fix it, we need to edit the source program, not the dump. Well, wait. We'll do the dump. Let's dump this bytecode. How do we do that? Cout p1 dot dump bytecode. There we go. Got all of this, and oh, I didn't mean dump bytecode. I wanted the AST to be dumped. Yes. So let's do this. AST dump. That's what I wanted. Evidently it doesn't work. Oh, do I have a get AST? Find out. Oh, okay, I do still have to use the arrow. An optional shared pointer has to basically be dereferenced twice. That's why. Okay, so let's look and see what this contains. We've got a block, assign, left-hand side is, so A is assigned the array value. Ooh, I need to indent these more. I'm going to change that right now. Don't tell anybody. What is that going to be in? That's going to be in source AST node array. And the dump indent plus oh, I need another plus sign. Evidently I forgot how this language worked. Let it get caught up. There we go. Okay, so A is equal to an array that of 1, 2, 3. Then we are printing, and there's an index statement, so it is A indexed 0, so A sub 0. Then print A sub 1, and then print A sub 2. Now we have an assignment, and the left-hand side, there's an index where the collection is identifier A, and the index is 1. And the right-hand side is foo. And then the rest is exactly the same as the previous. So what we don't have support for is this assign left-hand side index collection, blah, blah, blah. Okay, that's what we want to write code for. So how do we do that? Well, we need to go into, did I open this already? No, I did not. So we're going to edit the source for program execute. And no, not program execute. I'm wrong. Even though we will need this, I'll close it for right now. We need, where is that going to be? Where it's compiled. And the question is this AST node, there it is, AST node assign. So we have an assignment node. And why did we not put this in a binary? Because technically assignment is a binary. The reason is because it operates differently than the plus, minus, multiply, divide, modulo, less than, greater than, all of those. Just like the and or do as well. So what we do here when we're compiling it is we say, is the type of the left-hand side an identifier? If so, then, okay, do that. Now, we should have, first I'm going to put that down, and I'm going to close it and then say, we don't have a way of pushing an error onto the stack. No, I mean, this is in the compile. For right now, I'm going to leave this blank. Okay. We haven't really talked about how we're going to handle compile errors. Oddly enough, this laid into it. But again, when you're writing your own programming language, if you don't write it, it doesn't exist. So we'll have to think about that. So what we need is, instead of AST node identifier, we need AST node index. And if we've got AST node index, then we need to do our conversion. Really? There we go. And what are we converting this to? INDE index. There we go. And I bet in AST node index, yeah, because I haven't included it. Oops, that was a mistake. Index, AST node index. In AST node index, so I'm going to go into it, include AST node index. There we go. The collection, well, that's I'm sorry, I know I just stopped talking. The collection and index itself are private, and we need access to that. So I could declare a friend function, but I don't like doing that. So what I'm going to do is I'm going to declare see, these AST nodes, they should have to say standard shared pointer. Why do they not? I don't think I've got a stray using namespace standard somewhere. But standard shared pointer to an AST node. And it's not quite. Well, I can put. It's okay to put the const first, even though technically I think that putting it afterwards is more consistent when you have to have multiple consts in the statement, but this should be fine. Ampersand. This is going to be get collection const. That's fine. And get index. Now, because these are not overrides, we have to write a little bit of documentation, and this is just going to say return a shared pointer to the AST node serving as the collection so at return the collection into which we will index. Okay. Return a shared pointer to the AST node serving as the index. Return the index expression. Okay, now we need to write these, so now it's gonna tell me that this is oh yeah, unused variable. I know that. Not done. So we need to edit the source. Before I do that, might as well just yank that. Okay. Edit the source for AST node index. There we go. All right, and then this get collection, get index should compile. Well, we're not there yet because we've got to go back to which code is this? AST node assign, and that is 5. All right. So buffer 5, we're now down to this. And so what do we need? We've got to turn this into bytecode. What does the bytecode need? It's going to be ultimately a new opcode. And what is the opcode going to be called? Index assign. Sure. We've got an assign. No, we don't have an assign opcode. So you know what? I'm going to do it assign index because there's going to be another assignment type when we use a period. So we'll call this assign index. So that is going to be the last thing. But what should assign index be wanting? It needs to know what identifier it's going into. So it needs to be this, not a this, because this is this is the assignment one, right? So we've got the left hand side convert, so it's LHS convert, and it's going to be an AST node index. So dot oh, what all does the index have? It has the collection, and that we need to say compile, pass it the program. That's fine. Now we need the index, compile program, and the right hand side is already on the stack. So the right hand side is going to be right hand side is on the stack, then the collection, and then the index and assign index. And should be get collection, get index. There we go, because I just wrote these methods. Compiled. Oops, wrong button. There we go. And now it says, hey, I don't know what assign index is. Good. Why is that good? Because that means everything else is compiling. Well, sort of. Okay, so we will edit our includes for our opcodes. And where do we want to put this? Return, print. You know what? I will put it up at the top. So function is creating something. Let's put it right after function. And this is going to be assign index. I need a comma too. So it's going to be pop index, pop collection pop value push collection index equals value. You're pushing the result of that, so there. So I've got assign index. Now we need to, it's going to give us errors because, yeah. Why do you not like that? That shouldn't be considered a temporary. What am I missing? Returning a reference to a temporary. This arrow collection is not a temporary. You know what? Easiest thing is to get rid of that and then get rid of it in the .hpp. Segmentation fault. Why? Because we haven't told, I don't think we've, well, it probably needs to remake everything, but let's edit the, oh wait, do I already have it open? No, I don't. Edit source program dump, and this was right after function. Yeah. And what did I call this? Assign index. Assign index. Not doing yeah, because all the work is done on the stack. So that should be fine. And it's still going to complain or still have a segmentation fault. But now I need to go into the source program execute. Again, look for function. Got that there. Assign index. And we need a stack check of 3. And we'll say auto index is equal to stack back stack.pop back. And now I'm going to get two more things. What is this? This is going to be the collection. And then this is going to be the value. And now stack.push back. What are we pushing back? The result of collection arrow, and we're going to create a new dunder, and that's going to be assign index. All right, assign index. And so what do we need to push in, or what do we need to provide it? The index and the value. PC ++ PC break. That's it. Now, it's not going to be able to compile. Oh yeah, I need a colon. That's why I can't compile. Yeah, assign index doesn't exist. We're about to add that. So in order to do this, we need to edit the include for computed expression. Yes. And just go down. We've got our is equals. We've got our dunders. And since we put it above add, let's put it here. And we're just going to say perform an index assignment using the or should it be to the supplied value. So param, the first one is going to be index. The index to which the value should be applied. The parameter of the value, the value to store, and return the result of the operation. Simple enough. This is definitely going to be a virtual. Garbage collected, dunder, assign index, passing in a but this is not a const because it is going to be modifying. Yeah. And now we need to edit the source of computed expression and add this. All right, and we just need to, whoops, didn't mean to do that. Don't know how to assign this value to the index. Location. We want that. Okay, now. In the execute, we don't have a call to even though I just wrote it. Okay, so what's the problem? Oh, whoops. So, if you're not seeing what I did, I need 2 of these. This is index and then value. And now I need to also put that here. Index and value. That was just copy paste error. Should give me an error. It shouldn't still pass, but oh, we're still getting a segmentation fault. So at this point, I don't think we should be getting a segmentation fault. So sorry, recompiling. It'll go faster if I use the -J whatever option. Tell it to use more cores than just one. Not getting a segmentation fault anymore. So it's not doing the assignment, but that's because we haven't written the assignment yet. We wrote a default function that will just say, hey, I can't do this. That's good. We will need that in just a moment. So now we need to go into the computed expression for the array. So edit the, first of all, the, before I do that, just copy that assign index. Now, edit the include computed expression array and just assign index. And don't forget to add at the end override. We've seen how handy that is when refactoring. Now we need to edit the source for a computed expression array. And paste it in. Now we no longer need this may be unused for the index or, oops, that, I just keep hitting the wrong button. I'm sorry. All right. So, what do we need to do? We need to first of all say, is the index an integer? If so, let's just yank that. So if the type thing, if it's an integer, convert it to an integer, and I is the value. Now we need to say, hey, is it greater than 0 and less than the size? If it is, then all that we need to do is say this arrow contents I is equal to value, and return that. Is that all? Yeah. Because we're setting it to the value, and then we return that value, which is what it should be doing. Did I hit? Oh, I'm not watching, that's why. Let's see. So what am I doing? First of all, this should be computed expression array. And we passed our test. We could get rid of. Where is the test? Oh, it's in the very first one. There we go. Recompile and it'll pass the test. So that's good. Let's do test my theory. Instead of that, let's say A4 is equal to foo. Oh. It should be 1, 2, 3, 1, 2, 3 because nothing got changed. This should have resulted in an error. We can test that in just a moment. In fact, we can do that here, and now we don't have to worry about constantly there we go. A is equal to, nope. Oddly enough, this should... Okay, I'll do the raw string. So that I don't have to constantly escape. But if I say foo, that should compile, but it should give an error. So if I say execute dot get result, it should return an error, and that's not going to be the right error message, but that's not the point. The point is to just do it. Get results is a function that I should have called. Index out of range. But okay, I'm going to go back to a is equal to and just say a sub 4. And since that's the last statement, the error should still be on the stack, and that's what will get returned. And it's still out of range. Good. That's what I wanted to see. But it doesn't crash our program. That's a good thing. So what do we have? We have now tested that we can't set something out of range, that we're not, that our change actually works, that it works from a not just well, wait, what's the difference here? Oh yeah, if it's out of range, it doesn't change anything, and the original is unchanged. Yeah. So it gives us an error if it's out of range, and it doesn't change anything if it's out of range. And when it's in range, it does change one thing and nothing else. I think that's our tests. Do we need to test anything else? I don't think so. Did I save that? Because we should be passing everything now. Evidently now I have saved it. Okay. Let's see what all of our changes are. Bunch of them. Oh, I have spaces. This is in AST node index. Get collection, get index. Include AST node index. Okay, that's fixed. Makes sense. We added our assign index. Assign index, that's okay. That's all. I've got a lot of extra spaces at the end of computed expression array.cpp. Hello? There we go. So vim source computed expression array.cpp. Go back. There's our tests. I don't know. What do you think about using the brace closures so that I don't have to keep on renumbering things? To be honest, I kind of like it. Do we want to go back and refactor everything? Oh, that'd be 1,000-line refactor. Maybe if we have to touch it, we'll refactor it. But for now, everything there's nothing, no new lines, that is. Add index assignment only implemented for arrays. And by the way, maybe we don't need to implement it for anything else. I mean, we should be able to, when we use strings, be able to index into a string. We haven't written that yet. But I don't think you should be able to change a string by assignment because it's not the same as a C string, especially when we're going to be dealing with Unicode characters. So, yeah, that's what I think there. But only 113 lines added, and remake our docs. Since I didn't have to add any lines, I probably should have just ran it without. But oh well. Nothing else? Okay. What episode is it? Oh yeah, 42, the answer. Never mind. For episode 42. I don't have to keep going back to that screen. I could just say get log and I would see, oh, episode 41 was the last one, so we're obviously on episode 42. That's fine. Get push origin master. It's all up there. Get tag. All right, it's there. Always like to check how we're progressing. Our code size is respectable for the size of the project. Does this mean we're about halfway done? I hope we're more than halfway done. But I don't know. It's always hard. Once you start, it's like once you've written 90% of the code, you're 90% done with your project. Then the remaining 10% takes the remaining 90% of the time. I don't remember who came up with that quote, but it's, yeah. We're writing a lot, but it's going to be those little pieces at the end that are going to take up a lot of time. So things like the string library. Once we get strings working, that's fine. But it'll take a little while to fully flesh it out. Not just to get the length of it, but other stuff. Or what about adding dates to it? I mean, you want somebody to be able to get the date in their template, you would think, but what format for the date? And oh yeah, formatting. Well, right now our floats are always formatted as 6 decimal places. How do we provide a formatting function for numbers? You get the idea. There's a lot of little things that need to be added. And, well, Yeah, that's what we'll have to uh, think about as we as this project is maturing. But but for right now, we have arrays. We can index into them to get their values, and we can set their values. We can't append to an array. We can't delete from an array yet. Um, Hopefully that will come. Yes. Uh, so why am I saying that? Well, that's going to require the bound functions, right? So what's a bound function? Well, first of all, the only functions that we have are the compiled functions. So we need to add native functions, like library functions, like date would be a good one. And then we need to add bound functions, which are basically native functions that are bound to some sort of object. For better words, for lack of a better word, a computed expression. So, for example, you should be able to say string dot length, and it tell you the length. You should be able to say if you've got an array dot append, and it append. But anyway, that has to wait until we have this idea of a bound function, because the again, the bound function is bound to some computed expression, and that's how we'll implement it. So technically, anything could have a dot operator, but I don't want to do that in the format of. I don't want to think of it like, for example, Ruby, where everything is an object. It's not that strong of an abstraction. At least what I'm saying it's not that strong of an abstraction. But that will come. We will go in that direction, and that's something that we need to add. And then once we add that functionality, however, it will be very simple to extend what is um, what is available for these different types. And that's something I'm looking forward to. But for now, I think we've come to a good stopping place. And it's a shorter video than normal, which is good because it's been a long day. And but also you're probably sick of 2.5 hour long videos. So this is just barely over an hour. So once again, thank you. I hope you've enjoyed it in some ways, and have a great day.